All right, today we're going to be talking about Chapter 5, Lesson 1. It's called Algebraic Expressions. So, first of all, we have to talk about what each one of these types of things mean. So, first of all, each one of these are called terms. And that's what I'm going to use to refer to them in the future. But what this literally means is 6 times d. We have two things in this area here now. We have a number and a letter. So we have a number and we have a letter. This next term, this is 9 times s times t. Again, we have a number. But now instead of having just one letter, we have 2 letters. This next one here, this next term means m times n. And now we don't have a number, but we have 2 letters. And this last one here, this right here, this is called an exponent. And an exponent tells us how many times this here, which happens to be called a base, gets multiplied together. So it's a times a times a. There are 3 of them because the exponent is 3. And again, we have 3 letters. So the 2 numbers that are written in purple, what we call those are coefficients. And those are the numbers that are written in purple. What a coefficient is, it's a number that's attached to a term. And then we have these green letters. Those green letters, we call them variables. And what variables are, it's kind of like a placeholder for something that we either don't know yet, or we can choose what that becomes. So for example, in the term 6 times d, we can choose different things for d, and we'll get a different evaluation of it. But 6, the coefficient, that does not change. So the variable allows us to change things. The coefficient does not. All right, let's look at a couple of examples here then. So example 1, it says to evaluate 3 times t minus 4 if t is 6. What this means is we're going to substitute 6 in for t and solve. So what I'm going to do is wherever I see the variable, that's this number here, or this letter, t, I'm going to substitute a 6 in for that. So instead of having t minus 4, I'm going to have 6 minus 4. Order of operations now. So we have parentheses first. So 6 minus 4. This evaluates to 3 times 2 now, which evaluates to 6. Example 2. Same thing, the only difference is now we have two different terms with two different variables. So I'm going to substitute 4 for s and negative 2 for t, and then solve. So wherever I see an s, I'm going to substitute it for 4. So this is going to be 6 times 4 minus 3, my coefficient, times t, but I'm substituting negative 2 in for t. Order of operations tells me that I need to do multiplication first. So 6 times 4 is 24, minus 3 times negative 2 is negative 6. Think back to our integer rules. If I'm subtracting a number, this means adding its opposite, which of course evaluates down over to 30. Last example on the page, 3m squared, that's what this means here, there's 2 of them, minus 4, if m equals negative 3. So again, I'm going to substitute negative 3 for m and solve. So wherever I see an m, I'm going to put negative 3 there. Order of operations tells me that I do exponents first, but remember, if you recall from the very beginning of this lesson, the exponent talks about how many times the number in front of it gets multiplied together. So this is really going to be 3 times negative 3 and another negative 3, then minus 4. Don't get confused. Yes, there is a negative sign out front that kind of looks like a subtraction sign, but really this whole number is by itself. This whole number is by itself, and there's nothing that separates those two parentheses. So if there's nothing that separates parentheses, like a plus sign or a minus sign or a division sign, it's multiplication. So, integer rules tell me, as I multiply, same signs get me a positive number, opposite signs gets me a negative number. 3 and negative 3 are opposite signs, so this is really going to be negative 9 and negative 3 minus 4. Multiply these two numbers now, we have same signs, so negative 9 and negative 3 is a positive 27. And now subtraction is the last thing that gets done, so 27 minus 4 evaluates to 23. All right, let's practice a word problem now. It says the formula for converting Fahrenheit to Celsius is 5 times, in parentheses, F minus 32, and all of that divided by 9, where F is the temperature in degrees Fahrenheit. So what we want to know is what is the temperature in Celsius if it's 77 degrees Fahrenheit. So what this means is I'm going to substitute 77 in for F and solve. So let's go ahead and do that now. We have 5 times 77 minus 32 divided by 9. Parentheses first, 77 minus 32. Starting to simplify now. 77 minus 32 is 45. 5 times 45 is going to get 225. And then 225 divided by 9, because that's the next part, is going to get you 25 degrees Celsius. So 77 degrees Fahrenheit is the same as 25 degrees Celsius. As we go through this word problem has units, which means your answer also has to have units. All right, last part here then. It says writing expressions. It says write a word sentence into a number sentence. Is essentially what we do when we start writing equations. So what I like to do with a word problem here is I like to highlight what I feel is really important information. It says, Leah read 20 pages of a book. She plans to read 5 pages per day from now on. Those are important information because they have numbers. So she's already read 20. And the other one is 5 pages per day. So it says, write an expression that represents the total number of pages that she will read in D number days. That's important too because now I have a variable. And then find how many pages she will read in 7 more days. That's really the question that we're looking for. So how many pages will she read in 7 more days? So as I go through this, 5 pages per day is going to be something that's in my number sentence. The 20 is also going to be somewhere in my number sentence. So is the variable D, but I need to figure out where it goes. So I can look at the 2 numbers here. It says 20 pages of a book. Doesn't say how many days she read it in, doesn't say that it's something in the future. This is something she's already done. This here says 5 pages per day, which means that if we do 2 days, it'd be 10 pages. 3 days, be 15 pages. So this D gets attached to the 5. And we know it's going to be multiplication because it's 5 pages per day. So we want to multiply by the number of days. Now we need to figure out what goes between these 2 terms. It says she's already read 20 pages, and she plans to read 5 pages per day from now on. So she's going to be adding the number of pages that she'll be reading from now on to the total number of pages she's already read. Last part now, we need to solve this question. It says, then find how many pages she will read in 7 more days, which means we're going to set D equal to 7. Because D is number of days, we want 7 more days. So I'm going to substitute 7 in for D. So now I have 5 times 7. Remember, there's nothing between these 2 numbers, this number and the variable, which means it's 5 times D. And then I'm going to add 20 onto it. So 5 times 7, order of operations says multiplication before addition. So that's 35. And 35 plus 20 would be 55. Now, with a word problem, every answer has a meaning. This answer, or this number, answers this question. So how many pages will she read in 7 more days? Well, she'll read 55 more. Or how many pages she'll read? She'll read 55 pages. So Leah will read a total of 55 pages after 7 more days. And it's not 55 plus the 20 she already did. That 20 is included in there. All right, that is the end of lesson 1. If you have any questions, please let me know.